Let's see here. We get that. And did you get it? Okay, let me get out Romero's.
I'm not qualified to do this. You're going to tell me after the second week. So you know everything about NASA Ames Research Center, right?
No.
You're teachers. Yeah, I get to ask you questions. Oh boy, oh boy, oh boy. This is signed by the president in 1915 that established the National Advisory Committee for Aeronautics.
1939 was when the space started.
Nose of the aircraft due to the individual tiles. And so we relied on wind tunnel testing to understand how the boundary layer would grow over the tiles and the flow when you talk about this. So I call this an exoskeleton.
Exoskeleton.
Say it again. Exoskeleton. It's got the skeleton on the outside.
I'm holding the door for you, yes.
He's a gentleman.
And we're all entering the 80 by, what's it, the 80 by 120 wind tunnel building.
We looked at the sheathing area on the side of the tunnel, which housed the drive system. We looked at the new leg of the tunnel that was added in the late 1980s. The original 40 by 80 facility was 200 knots, about 230 miles an hour. Aircraft at the time flew up to about 400 miles per hour. So this facility could go a little bit over half the speed of the max speed of let's say a fighter aircraft at the time. Wind tunnels use a drive system. Outside, I mentioned that the air is incompressible. It's like water. This is just exactly what you experience with. This facility is called a closed circuit wind tunnel. This is called an open circuit tunnel. You cannot run the air in both test sections at the same time. We're going to walk out into the wind tunnel here shortly, and you'll see that this vane set is mostly closed. And that shuts off this leg from the closed circuit facility where we're currently testing in the Fort Dix question. Up until 1987, we would test in this section because that's the only one we had.
Right.
All right. What did we do? We added another test section. This test section has 3 times the cross-sectional area, allows us to test larger models. But when you do that with the same drive system, that means although it's 3 times larger in cross-sectional area, it has 1/3 the airspeed. It's just an area ratioing of the speeds. And so, although this facility, when we upgraded this part of the facility, we went to higher power drive system so that we could get 300 knots. Originally it was 200 knots. Now 300 knots, about 345 miles per hour. And we get just over 100 knots in this facility here, 115 miles per hour. So now you have a big tunnel, but the flow is really pretty slow. There are tunnels here that can test up to Mach 8 times the speed of sound. Maximum speed here is about Mach 0.3, much slower than this. So it's 228,000. Okay, all the power for Knox, Tennessee is being used in this facility when we turn it on and we run at max speed. Now you take it one step further and you say, okay, this wind tunnel has a footprint of 8 acres. That's the equivalent of 225,000 people on 8 acres. That's almost like a rock concert, you know, in the middle of nowhere. Burning Man in Nevada Electricity runs facilities like these. And this is not the highest energy user at the center. The highest energy user time, please.
You gotta say that one more time. Okay, ready? Okay. One.
The acronym is HIADS, Aerodynamic Decelerator. It is the new technology that's going to allow us to enter the upper reaches of the Martian atmosphere to slow the capsule without allowing the capsule heating up so that it can enter into the Martian atmosphere, then to be able to deploy another parachute and be able to land and safely on the Martian. Coming down the runway was actually
space shuttle parachute.
The drag chute get buffeted by the weight coming off of the space shuttle, and that buffeting actually caused the cables to go feed back into the space shuttle, and the space shuttle was going down the runway. And come on here.
Whoa! Watch where you walk. Oh, look at the ground here. Okay, this mesh.
All right, 80 feet high, 120 feet wide. You know, you go to kids, you give them something, you give them numbers, and you know what you should do? You give them the numbers, then you say, why? Why is the wind tunnel 80 feet high, 120 feet wide? Why is it wider than it is tall? I'm not going to move.
Would you like the answer?
Yes. What do we test in the wind tunnel?
Bigger, wider things.
What like airplanes?
There we go.
All right, give me an airplane. You gotta give me an airplane. Show me an airplane. Thank you. You're wider than you are tall to fit the test articles that we're going to have. If airplanes were basketballs...
Oh, cool. This rotates, this whole section.
We don't have to need that. Okay. We put the models in the center of the test section because that's where the best flow quality is, 40 feet up in the air. Do a test in this facility. After 2 weeks, your neck's hurting because the model's so high up in the air, you end up deciding, I'm not even going to look off the nose of the airplane. So what we do is we have the struts attached to a T-frame, and the T-frame is mounted in a turntable. I love talking to kids these days. How many of you ever heard of a turn? And then I have to go, and they go, oh yeah, I know that. All right. Now, you can rotate the turntable 180 degrees if you wish, and then the tail strut becomes a nose strut, depending on how you want to mount it at the top. There's 8 to 12 inches of acoustics on the elevator, and you bring in pieces. It's okay. It's good. I asked this, what's that? It comes up through the floor. The answer to that is 15 minutes to open from floor to ceiling.
Huge barn door opening wall.
There, and literally, we open up the wall of the tunnel to bring the model in. On the other side of the tunnel is the large yellow gantry crane, capable of lifting 150,000 pounds. When the facility opened in '87, that was the world's largest gantry crane. That gantry crane comes into the facility because we open up the wall to wall and from ceiling to floor. But the air is coming in from the outside, and so the floor comes up, the ceiling comes down, the walls come in. It's a 6-to-1 contraction ratio. That means the velocity at the inlet itself is, if it's, let's say, 10 miles an hour, it's 60 miles an hour here because of that 6-to-1 contraction ratio in area. All right. Now, originally when we built the facility, they were talking about putting a lake outside the inlet that would allow for very calm, still air to come over the lake. Instead, we got an ultimate frisbee field. Oh, and we got the rollerblade hockey guys down there that keep the floor clean for the Air Force so things don't feel set on its edge. Each of the vane sets is individually splayed, so that as the air comes through the contraction and it gets to this point here, it has uniform velocity from one wall across the other wall. There is fencing on the forward part of the vane set and on the aft end of the vane set. Wind tunnels will have fencing to chop up the turbulence and allow that turbulence then to decay as the air progresses away from the vane sets. That's not why we put the fencing here. Why? Oh,
I've already been picked up.
Okay, all right. Why did we put fencing on the far side and on this side of the inlet?
To control like debris,
All right, that's all. You're on the right. You're on
like
the right.
trash and stuff.
Ah, good. What we hear, if you sit really quietly, you'll hear large enough for us to test air-breathing engines. And air-breathing engines suck in the air, and so if you had birds flying into this area here, they would end up getting sucked in, and that's called foreign object damage, or FOD. Now, if that gets to you, realize that the little birdies aren't going to come in because we got the fence up. We don't have to worry about the little birdies. Oh, but wait a second. We open these big, gigantic doors. We always get a pigeon to fly in, but then the hawk comes flying in right after it. They go bound by the drive system. In 15 minutes, the hawk leaves with a smile on his face. And we don't have to worry about the poor little pigeon.
Now, I noticed when I was caressing the pylons at the front end, feels like there's bugs splatted on.
Oh yeah, bugs can get through the fence real easy here. So
that doesn't bug the aerodynamic engineers.
No, that's a good question. And recognize that the drag of an airplane is very sensitive to the flow over the wings, and the flow can separate due to bugs or things on the airfoils. We talk about coming up with laminar airfoils where the flow over the wings is perfectly smooth. And the expectation is that we're going to be able to build and maintain and keep the surface perfectly smooth. Did he just write his name there? All right, let's walk on out here. We got about 5 more minutes, right, Brittany? No, in this facility we use wood blades. We've done that since '44. When we rebuilt the facility in the '80s, we used wood blades again. We considered using composite blades, And those costs would have been $1 million more. Turns out the wood blades that we use right now were made by Permally Gloucester in England. It's the same wood that was on the Spitfire propeller in World War II. It's a patented wood process. It's really quite neat. It's 3 times denser than normal wood, and of course 3 times stronger. Any other questions here?
At the end, can we take a picture photo with you in it?
I would be very pleased and proud to have that opportunity to do it. Okay, but now you make that question, I can tell one more. Recognize the control room is down on the first floor, and we use cameras to display what the model's doing and what the testing's being done in the control room itself.
Window for the observer.
But it's always the window observer that sees things and can notice that something's happening. And he's got a headset, he's got binoculars, he's got communication to the control room. He also has a kill switch to be able to shut off the drives. I was watching the Jay Leno show at night. They were going to do a stunt there on the stage right there in front of the live studio audience. They had a cannon. They had the plexiglass. They put a watermelon inside the cannon. And behind the plexiglass structure, about 15 feet away, there stood Betty White. Oh, no, absolutely right. I can't believe it. Poor Betty. Who's going to win? The watermelon or Betty White? It's the same plexiglass. We know that that will withstand the blows of a 23-millimeter shell. I mean, come on. It's going to stop that, the watermelon, but this is Betty White. This is, this is good. This could be disastrous, Betty White taken out on the Tonight Show. They fire the cannon. It's in super slow motion. The watermelon comes in. It goes splat. They show Betty White. She doesn't even flinch. And you know why? Because she's Betty White. Let's take that picture. Major General Charles Bolden, retired United States Marine Corps. When Charlie, that's why I know him by first name, I've traded emails with him, he's the kindest, world's nicest gentleman. He has a hell of a job, but he's the nicest gentleman. When he got called into Barack Obama's office, he got interviewed for possibly for his nomination to go to the United States Senate. He came out of Obama's office, interviewed by the White House press corps. They clamor to him and say, Charlie, what did President Obama ask you to do if you get approved to be the head administrator of NASA? He said he's told me one and only one thing. Inspire and motivate the next generation of young people so that we can live in the society that we want our children to live in. God bless each and every one of you for the job you do. Thank you very much. Keep up the energy. Keep up the spirit. You're making a difference. I love you all. Thank you very much.
So our tour guide today was Bill Warmbrodt, and we sure appreciate it letting us check everything out here. That was very nice. We just finished our tour. We came through the breezeway. When we're inside the tour, right there, that was the door, the side of the wall that would open up. There's the crane. Whoa, pardon me. Sorry about that. There's the crane that they use to move in and out of aircraft. You can see the tracks that roll it over. So that's pretty neat. And then over there, this is the back side of the front side of the air intake. So that's pretty neat. Totally cool. Wow, this is a breezeway, isn't it?
It is.
Team building. What is this? Day 7, day 8, something like that. Fuel!